This video is going to go into the details of what different types of reliability exist and how to measure them. The reliability question. Is this research method consistent? You can always be asking yourself this question. Reliability is all about consistency. Consistent results over time, consistent results for the same person, consistent results for different people, consistent results for different versions of the same methodology. You get the idea. It's all about consistency. You could imagine reliability as a bridge between the methodology of an experiment and the results of that experiment. It's like your results are a specific location on one side of a river, and the methodology is the bridge that researchers use to get their samples to the other side. If that bridge is stable and well built, then people will always land in the same place. But if the bridge is wobbly, or it moves, or God forbid it breaks, then those results are not going to be in the same place on repeated attempts. The world is noisy, and there's a lot of randomness that the experimenters can't always control for. There are normally many different ways to measure the same thing, and there are many different factors which could affect the results of an experiment. The point of experimental design is to build an experiment, in this analogy represented by the bridge, that can withstand loads of different changes in the environment. You want your bridge to be as strong and stable and consistent as possible. So how many different ways are there to be consistent? Today I'm going to talk you through the reliability checklist that you can use whenever you are critiquing scientific research or designing an experiment. The different types of consistency generally split out into two categories: internal reliability and external reliability. And this internal-external split can generally be mapped onto the classic within versus between dichotomy used in research. Internal reliability asks, do I get the same results again with the same conditions? External reliability asks, do others get the same results between different conditions? For example, imagine a pianist practices the same piece repeatedly in the same room on the same piano. If their performance sounds the same across each time point, this reflects internal reliability. The conditions are tightly controlled and unchanged. Now imagine the pianist performs the same piece on different pianos in different concert halls for different audiences. If the quality of performance remains consistent, this reflects external reliability. So, as you can imagine, for external reliability, you can measure the same tasks on the same people, but on different days and under slightly different conditions. For example, time of day or environment. This is called test-retest reliability. Test-retest reliability is all about showing that your results weren't a fluke and that they weren't influenced by a novelty bias or by random factors. If the tasks are measuring something consistently, then the results should be similar no matter when or where the participants do the task. Then you can also measure the same tasks between different people and see if the results are consistent. This is called inter-rater reliability. Essentially, your participants change, but the tasks stay the same. If the tasks are measuring something consistently, then the results should be similar no matter who does the tasks. That's inter-rater reliability. Quick side note is that test-retest reliability is something that a lot of researchers forget about in experimental psychology and cognitive neuroscience. So keep an eye out when you're reading papers. When experimenters do forget about it, a phenomenon known as regression to the mean can cause havoc with the validity of your results. I'll do a separate video on the regression to the mean at some point in the future, but just for now, know that designing experiments with strong external reliability will protect against the regression to the mean. Okay, there are two types of internal reliability. One is where you create different versions of the same tasks to see if you get similar results. This is called parallel forms reliability. An example might be that you're studying decision making, and in your original task, there were different rewards and punishments depending on what decisions participants made. In your parallel versions, you might change the structure and positions of the rewards and punishments. If you're measuring the same underlying decision-making construct, then the results on the parallel forms should be similar. But if the tasks are not designed reliably, then the results will not be consistent, and this would show weak parallel forms reliability. And the final measure of internal reliability is internal consistency. This is where tasks that are designed to measure the same construct should produce results that correlate with each other. The technical statistical term is covariate. For example, imagine you've built a new decision-making task. We're doing a lot of decision-making at the moment. As well as testing this new task, you would want your participants to complete pre-existing decision-making tasks so that you can analyze whether the results from the new tasks co-vary with the results from the existing task. For a new task to be reliable, we would want to see that the results are internally consistent with pre-existing validated measures of that construct. Just like the validity measures from my previous video, you can have strong or weak reliability. So whenever you are reading a research paper, you can be thinking about the reliability checklist. Does the paper you're reading have test-retest reliability? Does it have inter-rater reliability? Does it have parallel forms reliability? And does it have internal consistency? Every experimental research paper can be ranked on these 4 dimensions systematically. If you want more ways to critique scientific research, then check out my other video on reliability next. See you soon!